Okay, Rochelle, I'm going to try to go through quickly uh, using that kind of area model to model the multiplication of the fractions, in particular the whole number um, by an improper fraction, which is what you were asking about. So the thing that I'm going to kind of emphasize here is I would want to make sure that the students understand what the multiplication statement is telling me. Just like when we learned whole number multiplication, we'll always go back to our understanding from multiplication, such as say 5 times 2, that means 5 groups of 2. So if I was to say do this, 2/3 times a half, I would interpret this as 2/3 of 1/2. So the way I would model that is I'd create an area model of 1/2 to start with. And so I might have something like that. And so then I'd want to color in that 1/2. So say that right there is my 1/2 of my area. Now I want 2/3 of 1/2 of this area. So I'm going to chop up my figure into thirds. Now I'm going to go all the way through and chop the entire area into thirds, like that. Okay, so now what is 2/3 of the 1/2? Well, I'm going to try to use a different color to illustrate that. 2/3 would be there's 1 and there's 2/3 of the 1/2 piece. But what is that actually equal to of the whole area? It is 2/6. And so that's the way I'd kind of illustrate that using the area model. Now I know you'll see it in some of the literature that you can just model the 2/3 as one dimension and the 1/2 is the other dimension. Where the overlap is where you get that product, which is great. That's exactly what you want to do, and you want to build on that. But I would probably start with this understanding, and then slowly lead into that, because hopefully what the students see is this is a simple enough calculation that it's 2 times 1 and 3 times 2. So now I might move into something like this, and again, since I've kind of developed the multiplication of two fractions this way, it's a little easy to make the transition now to this, which is 5 times a half. And so I'd say this is 5 groups of a half. 5 times a half means 5 groups of half. And so I'd want to demonstrate that. So I'd grab my area and I'd divide this in half, and maybe color in a half, and there's my half, and I want 5 of these. So this is easy enough to do with this software. I'm going to pick this up and just group this and copy that 5 times. And so there's 2 groups, there's 3, there's 4, and there's 5. So how many halves do I have? I have 1, 2, 3, 4, 5 halves. And that's my answer. So I have 5 1/2 pieces, or 5 halves. Okay. I'd also want to consolidate this and remind students that multiplication is an example of repeated addition. And so I've got a half plus a half plus a half plus a half plus a half and so on 5 times. And so we're kind of slowly building in the idea of adding and subtracting fractions, and so which is kind of nice, because then they kind of get this idea of why we don't add the denominators together and we don't get 5/10. We do get 5 halves. And so, and I'll just tidy this up and make sure it's nice and complete. And so we've got 5 of those, and we've got 5 halves. Okay, so now let's try an improper fraction by a whole number. Okay, so I've got 5 times 3 halves. So the first again, I want to remind students that this means 5 groups of 3 halves. So I first want to model 3 halves. So I'll take this and kind of create my halves. And so there's a half, and I'm just going to copy that and kind of be lazy here and group that so I don't have to. So there we go, and I'll just paste that. So now I want to model 3 halves. Well, there's 1, there's 2, and there's 3. So it's a 1 whole plus a half more. So I want 5 groups of those. So I'm going to again be a little lazy here and group those, and then oops, there we go. Copy that and paste it a whole bunch of times. So paste that there. So there's 2 groups of 3 halves, 3 groups of 3 halves, 4 of them, and then obviously the 5th group. So how many halves do I have altogether? So I can count these all. So I got 3 plus 3 plus 3 plus 3 plus 3. I've got 15 halves. So there's my solution, 15 halves. But again, I'd want to maybe show students again that this is 3 halves plus 3 halves plus 3 halves plus 3 halves and so on, all the way up until I get my 15 halves. And the nice thing again about that is it counteracts that common student misconception that when I add fractions, I add the numerators and then I add the denominators, and so they get some ridiculous answers. So it would be nice to kind of show that, again, this is 3 halves plus 3 halves 5 times, so that they can see that I do in fact have the numeric kind of solution corresponds to that geometric solution. There are 15 halves depicted here, and that's exactly what I have here. So hopefully that helps. The I know it's a struggle sometimes to kind of show the math, and sometimes it feels like sometimes maybe it's a little forced, and sometimes with multiplying fractions, eventually students kind of just do get the more efficient kind of way of just multiplying numerator by numerator and denominator by denominator. But if they're not there yet, then it's always good to go back to the geometric and that tactile approach of doing things. And so that area model is fantastic. So I hope that helps.